This lecture is on causal designs. So let's put this back into perspective. If we return to the marketing research process, remember we're going to formulate a problem, and then based on the nature of that problem, we choose a research design. So the three research designs are exploratory, descriptive, and causal. Recall that I said that the customer insight class is going to deal with exploratory. I'd say that a large part of this course has dealt with descriptive research. We had some discussion of that back in week 1, and we kind of put off causal designs. Now we've talked a bit about causal designs throughout. Today we're really going to go deep into causal designs. To kind of motivate why I think this is one of the most important lectures in the whole course, let's go to the IMC process. This is not in your course packet. You'll learn all about this when you get to the IMC process course. So this is the IMC process. We do things to understand customers. We establish their value. Based on that understanding, we can set objectives for the customers. Based on their value, we can get to how much we can spend on them. Then we go off and we create interactions. We do marketing stuff to them. The fourth step is absolutely critical. So it's the measurement. So in essence, that fourth step is prove to me that what you're doing is working. So that's something that advertisers have traditionally had a real hard time doing. Direct marketers have been better at it. So prove to me that it's working. So essentially what's going on is you have a relationship between the type of stuff that you are doing or recommending as a marketing professional and then the outcomes that you want to achieve with that. And so we really need to get at this link. So is there a causal link between what you do and the outcomes that you want to achieve? And clients will ask you to prove that link. And that's what this lecture is about. So let's see. We'll talk about causality in general. The way to get good proof of causality is to do some sort of experiment in a very general sense. So we're going to talk about experimental designs. Then we're going to talk about evaluating experimental designs. Are they good or bad? And then how do you analyze the results of an experiment? Here's a wonderful quote from Lester Wunderman, who's one of the fathers of direct marketing. And he's kind of pointing up one of the great virtues of direct marketing that lends itself to testing, which we could also say of internet marketing. So to this day, I believe the most important tool available to the direct marketer is the ability to test, which is a form of pragmatic research that doesn't just tell you how a consumer might react to an ad, but how consumers really do react. So direct marketing makes advertising totally measurable and accountable. So let's start in a kind of a philosophical mode. What is causality? So causality means that if I change one variable, I manipulate one variable, then that implies a change in another. Now, establishing that link between changing one variable, producing a change in another, is devilishly hard in a lot of cases. And the philosophers of science have come up with 3 necessary conditions to get at causality. If you look at the history of science, there have been some really lively debates over matters of causality. One of the most famous ones is does smoking cause lung cancer? And so for over a decade, epidemiologists and statisticians and other scientists had a had a very robust debate over whether that they could really make that causal claim. So the three things that we need are concomitant variation, time order of occurrence, and elimination of other possible causal factors. So concomitant variation is a fancy word for we need an association. So we go over to the scratch pad for a second. What we need is for if X is going to cause Y, then we better have something like this, where as X gets bigger, so does Y. Or we need something like this. As X gets bigger, Y gets smaller. All right, so that is concomitant variation. Earlier in the course, we called it just association. The two variables must be associated. Time order of occurrence simply means that the cause must precede the effect. So if my sales go up and then I change my advertising budget, I can't really say that my advertising budget causes sales to go up. All right, so the cause must precede the effect. These two are fairly easy to establish. It's the third one that's rather tricky. So we have to eliminate other possible causal factors, spurious association. So earlier in the course we had a slide called correlation is not causation. That's what this is getting at. We talked about how there might be a lurking W, an omitted variable, that is the cause of the association, that explains the association. That's what we're trying to avoid. All right, so the absolute best way to eliminate spurious factors is to run a controlled experiment, a randomized controlled experiment. When we can do that, great. Sometimes we can't, and then we're kind of stuck with what's called an observational study. So we'll talk about both of these things. So let's talk about experimentation. So what is an experiment? So an experiment is where the market researcher manipulates one or more variables. So these are the causal factors, the X's, and then observes what happens to the dependent variables, the outcomes that are of interest. Now we try to hold other things constant while we're manipulating the causal factor. So we want everything else to be constant so that we're isolating the effect of that one variable on the dependent variable. So the X's are the things that are manipulated. They're called independent variables or causal factors. The dependent or criterion variables are the Y's. Now when we run experiments, we usually have two groups. We have a treatment group and we have a control group. There could be multiple treatment groups, but the treatment groups get some new treatment, the control group doesn't. And then we compare the dependent variable across these groups. Now, when you're evaluating an experiment, experiments can be classified into two broad categories. And it's absolutely essential that you realize which category your experiment is in. So there are true experimental studies and there are pre-experimental or observational studies. If you've had a previous stats course, you've probably seen the word observational study. Statisticians call them observational studies. Market researchers call them pre-experimental studies. The difference between the two is really simple. So if the experimenter has control over who gets what treatment, so if the experimenter can assign people to different levels of X, you have a true experimental design. If the subjects in your study self-select into treatment conditions, you have a pre-experimental or observational study. So I mentioned smoking studies earlier. The smoking studies are one of the classic examples of an observational study because the subjects, so people, self-select into the treatment conditions. So whether that person smokes or not is up to the subject. It's not up to the medical researcher executing the study. We've seen a fair number of true experimental studies in this class so far. So your computer homework involving the personalization of ads for that German book company. Well, the book company decided which subjects got the personalized version versus the one size fits all version. So that's an example of a true experimental study. All right, so hopefully you understand the difference between those two classes of experiments. The reason why it's really important to understand whether you have a true experimental design or a pre-experimental design is this last point. So if the experimenter can randomly assign people to treatment conditions, you randomize away other possible causal factors. Okay, so these give you much stronger evidence that you've got causality. Whenever you have an observational study, you should be on high alert that there could be one of these omitted variables, one of these W's that's confounding your results. And so we've seen a lot of examples of confounds in this class, going back to the chapter 6 case where a supervisor was confounded with the difficulty overseas order. Now, in discussing experiments, it helps to have a notation to describe these experiments. So here's the notation we're going to use. X's will represent exposure to a treatment. So that's a change in the independent variable. O's are going to indicate an observation, and then R indicates random assignment. Movement through time is represented through horizontal arrangement of X's and O's from left to right. Let's do a little test problem here. Some manufacturer of women's cosmetics is planning to sell these products through mail order. The firm's management was considering the use of direct mail ads to stimulate sales of their products. So prior to committing themselves to advertising through direct mail, management did an experiment. A random sample of 1,000 housewives was selected from Memphis, Tennessee. The sample was divided into 2 groups, with each being assigned randomly to one of the 2 groups. Direct mail ads were sent twice over a period of 1 month to the prospects of one of the 2 groups. 2 weeks later, both groups were mailed the company's catalog of cosmetics. Sales to each group were then monitored. Well, what I want you to do is to identify the X, the Y, and then diagram the experiment. So let's start with the treatment. So the treatment here is exposure to these ads. So direct mail ads were sent twice over a month. So getting those 2 direct mail ads. Oops, let's go to my sketch pad and we'll clear this. So X is equal to exposure to the ads prior to receiving that catalog. Now what is the Y? Well, the Y is going to be sales. Now let's diagram the experiment. So when you diagram an experiment, you want to first ask yourself, is there a control group or is there just one group? And in this case, there is a control group. So the sample was divided into 2 groups, with each being assigned to one of the 2 groups. So the direct mail ads went to one of the two groups. The control group did not get any ad. So we have a treatment group and we have a control group. Now, how did people get into these two groups? The way they got in was random assignment. So with each prospect being assigned randomly. So that word randomly is really important. What that tells us is I can stick an R right here. So using random assignment, we assign people to the two groups. Then let's see what happens next. So what happens next is direct mail ads were sent twice to the prospects of one of the two groups. So X happens. And what is X? Well, X is exposure to those ads. Again, this is time. So time is going across. What happens next? So both groups were then mailed the company's catalog and sales were monitored. So we have a measurement on the treatment group and a measurement on the control group. Let's call that O2. So the effect of the treatment then is just going to be O1 minus O2. Now you might want to think about how would you analyze this experiment. Well, we would use an independent sample t-test. To analyze this. So we have two independent groups. We have one measurement on each. Therefore, it's an independent sample t-test problem. Okay, so we've now diagrammed this experiment. What makes a good test? Well, a good test is one where we don't have to worry about number 3. So we don't need to worry about spurious factors. That's one thing that makes a good test. So these spurious factors are also called nuisance factors. They're also called confounds or confounding factors. Sometimes they're called extraneous factors. Any of those are acceptable terms. One other bit of language for you. If you have a nuisance factor and you have not properly controlled for it, that nuisance factor is said to confound the effects of the experimental variable. So we've had a lot of examples of this where you have the difficulty of the order and the supervisor confounded back in the Chapter 6 case. With the smoking study, the smokers had a lot of other confounds. So they tended to live in places with more with more blue collar industries where there may be more other hazardous chemicals around. So that would be another example of a confound. Now, this ability to isolate the cause to our X as opposed to a spurious factor is called internal validity. So internal validity is the ability of the experimenter to unambiguously show a cause and effect in relationship. So if we see an effect, it's due to the thing we're manipulating. It's not due to some confounding factor. This is one thing that makes a good test. The other thing that makes a good test is called external validity. So external validity means that the results of your test will generalize to other settings. So what I learned from this test I can apply to other situations. Now let's think a little bit about internal and external validity on this Memphis Housewives example. So the question is this a good test? We want to evaluate this test using both internal and external validity as a criteria. So is this an internally valid test, and is this an externally valid test? Let's have this discussion on a discussion board. in class, we'll have the discussion in class. All right, good, thank you.